Question 15. Iron reacts with dilute hydrochloric acid at a constant temperature of 25 degrees Celsius. Which statement about the rate of this reaction is correct? So, the first reactant, iron, is going to be a solid metal, and the second reactant is aqueous dilute hydrochloric acid. The products of this reaction is going to be a salt of iron 2 chloride and hydrogen gas. The reaction between a solid and a liquid can have its rate affected by several different factors, first being temperature, second being the amount of the reactants, such as the mass of the iron solid used or the concentration and the volume of the dilute hydrochloric acid used. In a reaction involving a solid, the particle size can also affect the rate or the speed of the reaction, in which powdered solid particles can allow for faster reaction, because there is more surface area and higher chance of being in contact or colliding with the second reactant. Lastly, the presence of a catalyst can also help to increase the rate of the reaction by lowering the activation energy barrier. In this question, a constant temperature of 25 degrees Celsius is used, so we can eliminate temperature as a factor that is going to affect the rate of reaction because it is not changed across the entire duration of the reaction. The factor of particle size can also be eliminated because in this question it doesn't state anything about the particle size of the iron metal. A catalyst is also not mentioned in this question. So we should focus on factor number 2, which is the amount of reactants, specifically the amount of iron metal and hydrochloric acid across the entire duration of the reaction. We know that as the reaction proceeds, there will be less and less reactants available to react and more products produced. Therefore, the amount of reactants is going to fall over time, meaning the mass of the iron metal will fall. The concentration and volume multiplying both will give us the amount of the hydrochloric acid, which will also fall, and therefore the rate of the reaction will decrease due to a decrease in factor number 2, which is the decrease in the amount of reactants left available over time. Therefore, option A will be the correct answer. There will be no increase in the rate across the duration of the experiment because the question does not state any increase of these factors. There was no increase in temperature in the middle of the experiment, nor did they add more reactants to react to increase the speed of the reaction in the middle of the reaction. Therefore, there should not be any increase in the rate of reaction C. And the reaction rate will not likely remain the same because the amount of reactants will fall as the reaction proceeds. Therefore, A is the correct answer.